All right, let's apply some of this information in section 14.1 that we've been learning about graphs. So here's an example of a real-life problem. It says a metronome. A metronome is an inverted pendulum that helps musicians play to the beat. It kind of looks something like this. There's a base to it. It kind of looks something like this. But then it's attached to the bottom. There's a little pendulum. And the pendulum swings back and forth like this. And it helps musicians keep time or keep the beat of a certain piece of music. The number of centimeters that the tip of the pendulum is from a tabletop. So here's the tabletop in blue. The tip of the pendulum obviously gets closer to the tabletop when it goes this way, gets further away, and then gets back closer again. So the number of centimeters C that the tip of the pendulum is from a tabletop is modeled by this equation in the blue box, where T is time in seconds. T is time in seconds. And C is in centimeters. Letter A. What is the period of the pendulum? Well, if you recall the formula, 2 pi over the absolute value of B is equal to the period. Well, the B value is what's next to the T. So the B value is 4 pi. So if I put 4 pi into this equation down here, I find out that the pi's cancel and 2/4 reduces to 1/2. Therefore, the period of this pendulum is 1/2 second, or 0.5. Very good. B. What is the maximum height above the tabletop the pendulum achieves? Obviously, that's when it's straight up and down. This distance right here. Well, what is it? Well, remember the maximum is K plus A. K is 15, A is 3. So therefore, it would be 18 centimeters. Good. C. What's the minimum height achieved? Well, if you remember, minimum is K minus A. 15 minus 3 would be 12 centimeters. And you can test to see if the amplitude is correct, because the amplitude is 18 minus 12 divided by 2, which is equal to 3, and that certainly is our A value. So we're right on the money. D, what is the midline of this particular graph? The midline is always the K value, 15. Is there a phase shift? The phase shift is always next to the theta, or the x, in this case T. Is there anything that's added or subtracted in those parentheses? Well, the answer is no. So there's no phase shift. We don't need to worry about what it is. Is there a vertical shift? That's at the end, the K value. Yes. And what is it? It's a plus 15. The graph has moved up 15 units. All right, so there's our key pieces of information. Now, let's graph. Graph the height of the pendulum tip above the tabletop for 2 periods. All right, well, here's my y-axis. I'm in the positive numbers, if I remember right, because the minimum and maximum are both positive. So here's my t, or my x-axis, and here's centimeters, or y. Well, if I recall, there's only 3 numbers I need. And I don't care where you put these people. Just label them for me. The minimum is 12. The maximum is 18. And the midline is 15. So there's the middle of my graph right there. All right, now I got to go back a slide. The period is 1/2 second. All right, now this is going to be tricky. The x value, now if you remember, the graph starts at 0 unless there's a phase shift. I got to go back again. I forgot. Phase shift. Nope, we don't have a phase shift. So the graph will start at 0. And the cycle will end at 0.5 seconds. Now, it says graph for 2 periods. That's 2 cycles. So the first cycle is going to end at 0.5 seconds. The second cycle will end at double that, which is 1 second. Okay, good. Well, 0.5, let's talk about halves there. Half of 0.5 is 0.25. Half of 0.25 is 0.125 seconds. Now, if I count by 0.125s, I get 0.125, 0.25, and then right here would be 0.375. And there are my 5 lines I need to graph my equation. Okay, so I got to go back again. I forgot the equation. Oh, it's cosine. It's cosine. Well, where does the cosine start? It starts at either the maximum value or the minimum value. If this 3 was negative, it'd start at the minimum. Well, all right, fine. So I'm going to graph this in green. At 0, I'm at the maximum. It starts at 18. That means my metronome is straight up and down. Well, if it starts at the max, it ends the cycle at the max, which is at 0.5 because that's our period. How about halfway in between? Halfway in between, we're at 0.25. That's when we're at the minimum. That would be a height of 12 centimeters. Halfway in between this dot and this dot, right here, that's where it crosses the midline. And the same halfway in between there, it crosses the midline. So our graph of our height of our metronome is something like that. And now it says for 2 periods. So let's do that again. So 0.5 and 1 second, halfway in between would be 0.75. Halfway in between here would be 0.625. And halfway in between there would be 0.875 seconds. And it's going to work the same way. It's at the max at the beginning. It's at the max at the end. And then at 0.75, halfway in between, it's at 12. And then at these 2 numbers right here is where it crosses the midline. And I'm going to draw that just as a dotted wave so you can tell the difference between cycles. And there you go, people. There's your graph of your pendulum tip and how high it is above the tabletop. Obviously, its height oscillates. Now, let's answer some questions. Question number 1. John thinks that the amplitude and vertical shift should be switched. Could he be right? Well, I'm going to go back to my equation. Let's go back here. If we're going to shift the amplitude and the vertical shift, I would flip those 2 numbers around. Now let's see if I can get that new equation right. If so, it would be, If so, it would be 15 cosine 4 pi t, and then it'd be plus 3. Okay, well, could he be right? Well, question number 2 will help us answer that. What's the maximum now? Well, the maximum is k, which is 3, plus 15. The maximum is 18. Hey, that's still the same. Okay, that would be our maximum. How about the minimum? Well, the minimum would be the k value minus 15. Whoa, 3 minus 15, yuck, that's negative 12. People, how in the world can you have a height of negative 12? That would mean your metronome little dealy thing would be all the way down here. It would be flipped and rotated upside down. That's not possible. It can't go below the tabletop. Is he right? No. There's no way he can be right because that makes no sense. Number 3. How would the equation and the graph change if the period was 3 seconds? Well, that's where you got to go back to that formula, people. The formula 2 pi over b equals the period. Well, if the period is 3, I put that over 1 and I solve for b. So I cross multiply, I'd get 2 pi divided by 3, which would be my new b value. That would be this. So my equation, y equals 3 cosine 2 pi over 3t plus 15. Plus 15. That would be how my equation would change. This number in green and the green circle would change. How would that change my graph? Well, if the period is now 3 seconds, that means that this dot right here would be all the way off my chart, way over at 3 seconds. So basically, it is really stretching out this part of the graph. It is really dragging it this way. So your graph would look something like, and I'm just exaggerating here, don't copy this, but it's something like that, and it's going to be a big, long cycle. So I hope that answers your questions, and I hope that helps you understand a little bit how I want you to do the application problems that I'm going to give you in class over the course of the next week.